The next talk, William, yours.
Great. Hey, everyone. Great. Thanks for joining. Good to see everyone. Had a little, maybe too much yelling at the bar last night, so my voice is a little weak, but we'll try to give it a go. So this talk is building agentic GraphQL APIs with LLM tool use and knowledge graphs. You can find the slides, either that QR code or that short link there. So my name's Will. I work for a company called Hypermode. We'll talk a little bit about what that is in a second. But before we dive in, there's a lot of terms in the title of this talk, right? It ends up being a little buzzwordy. I didn't really intend that when I wrote it, but let's maybe level set a little bit and talk some about the pieces here. So the first one is GraphQL. How many folks are using GraphQL or have used GraphQL? Okay, maybe that's like half maybe. So GraphQL is an API query language. And so we have this strict type system. We define the types in our API, how they're connected. This is the graph piece. And then at query time, the client describes exactly the data they want to bring back, how to traverse through their application data. So GraphQL makes this observation that your application data is a graph, and you get back response that exactly matches the selection set, the pieces of the data graph that you said you wanted to be returned. I worked on open source GraphQL tooling when I worked at a company called Neo4j when GraphQL first was open sourced in 2016. And that was like a database integration where we were trying to generate a schema from a database, generate database queries from a GraphQL request. And as part of that work, I wrote this book published by Manning, Full Stack GraphQL Applications. This talk today is a little different take on how we're using GraphQL at Hypermode and some of our tooling. Anyway, so that's the GraphQL piece. The next piece of this is knowledge graphs. Knowledge graphs, I think, are having this resurgent interest now in the context of AI. It turns out that if you use a knowledge graph to keep track of your data and pass that context to these LLM AI models, you can really improve the results. And so we'll talk a bit about that. But what is a knowledge graph? There's lots of different definitions of knowledge graph out there. To me, a knowledge graph is just an instance of a property graph. So a property graph is this data model where we have nodes. Nodes are the entities, the things. They have a label, like the type, a way to group them. That's why we sometimes call this the labeled property graph model. And then we store arbitrary key value pair properties on nodes and relationships. So here's a very small knowledge graph. So I'm up there somewhere, a person named Will, employed by Hypermode. I'm giving a talk that has a topic, LLMs. There's another person up there, David Allen. He gave a talk yesterday. It also had the topic LLMs. We both used to work for Neo4j. So I think one of the important pieces of a knowledge graph is that there's some canonical representation of the thing. So for example, we have the topic LLM that's connected to a couple of talks at this conference. And when we have another talk that's about LLMs, we don't create a duplicate LLM node. We connect relationships to that one node. We have a canonical representation of the topic LLM. I think this is kind of the most important piece of this concept of a knowledge graph. When Google released their knowledge graph in, I want to say 2012 as part of the Google API, they talked about this concept of things, not strings. And I think that's a really good way to reason about knowledge graphs. Okay, so the next buzzword in my title is LLMs. How many folks are using LLMs to some degree? Yeah, a lot of folks. So these are models like Claude or some of the OpenAI models or the open source models like DeepSeek, which came out fairly recently, or Llama, which is made available by Meta. And the basic way we interact with these, we give the model some prompts, and LLMs predict text. So they're just predicting, given your prompt and everything I know, what are the most likely next strings of text, and that's what we get back. But we can also use models in more sophisticated ways. And there's this concept of agentic workflows for working with LLMs. Again, there's lots of different definitions of like what is an agent, but fundamentally I think an agent or an agentic workflow is just when your LLM is making a decision about the control flow of your application. This is typically done with what's called tool use or function calling, where you're defining tools or functions that are available for the LLM to decide to call, and you describe the type of data that you can get back from calling that function or that tools. And then the data is passed back along with your original prompt back to the LLM again, and you say, hey, this prompt with the new data, are we done yet? Or do you want to call another tool? And you sort of iterate on this until you get to the output. Sort of like the basic building block, I think, for this concept of LLM agents. So at Hypermode, this is the company I work for now, we build open source tooling to enable developers to build what we call model native apps. We'll talk about what that is in a minute. Our main open source projects are Modus, which is a serverless API framework. This is mostly what we're going to talk about today. We also build and maintain dgraph, which is a graph database. Anyone using dgraph? I'm curious? A couple folks? Cool. Badger, which is a distributed key value store, and Ristretto, which is a cache library. These are all written in Go, by the way. Go is a big piece of what we build with. And then all these projects are open source, Apache 2, build, deploy wherever you want, but the Hypermode hosting platform aims to be the best cloud hosting experience for these things. That's how we're supporting those projects. And so today we're going to talk about Modus, which is our serverless API framework that Hypermode builds and maintains. We released this, I want to say, in October, so fairly new in the world. So I mentioned this term model native app. What is that? Well, we think back to the three-tier architecture. This is how I learned to build apps, and this infrastructure still exists today, right? We have a client that talks to an application server, that talks to a database. If we want to scale this up, we need to deploy another instance of our application server, put a load balancer in front, and this sort of thing. And all those pieces still exist today, and apps still get built exactly this way. But I think it's the abstractions that developers think about that have changed, right? So instead of thinking about application servers, typically we're just thinking about functions and deploying to some sort of serverless environment. AI models, and we now want to incorporate as a first-class citizen into the applications we're building. And we're using different types of databases and APIs that are sort of built from scale for the beginning. So that's really what we mean by model native app, where the model is sort of a first-class citizen, and we're using more modern frameworks and ways to build and deploy our apps. Developer experience is really important in this world. So let's take a look at the developer experience for Modus. So we said this is a serverless framework. The abstraction that we think of for business logic is a function. So we write a function. Now Modus uses WebAssembly to target as many languages as we can for development. Currently, we support AssemblyScript. Anyone using AssemblyScript? AssemblyScript is a TypeScript-like language for WebAssembly. We also support Go. How many Go folks are there? Okay, cool, a lot of folks. And we're adding more languages soon, so Python's coming soon, other languages coming soon. We want to add as many as we can. So you write your function, and in the Modus SDK you have connections to data and APIs, abstractions for working with models. Your function is compiled to WebAssembly. We inspect the types that you've defined and the signature of your functions to generate a GraphQL API. And then when you query that endpoint from the client, Modus, because we're using WebAssembly, sort of using this execution plan that maps resolvers to functions that we've defined, has this sandboxed invocation specific to that invocation of your function. So WebAssembly gives us secure sandboxed memory space for each invocation, which is quite interesting. If we look at the components of Modus for the development, a lot of this is driven by a CLI. that exposes the way for skeleting a new app, for working with the SDK, for compiling and running locally in WebAssembly. Then for production, we're typically just looking at the runtime, and again, we can deploy this to hypermode, but this is open source. We can run this anywhere that we can run WebAssembly modules. If we dive into the Modus runtime architecture, some interesting pieces here are perhaps pointing out that there are host services, right? So there are functions that run outside of the WebAssembly sandbox. So these are our connections to models, our database connections, things like this. We mentioned this concept of the WebAssembly sandbox, which gives us these nice memory-safe, secure sandboxes for each invocation. Our runtime is built on top of the WA0 Go WebAssembly runtime, if anyone's using that. And then in the GraphQL piece, we leverage a lot of WonderGraph's Go GraphQL tooling to generate the schema, again, based on the types that you've defined and the signature of your function. Cool. So let's take a look at what using this looks like. Is that big enough? No. How's that? Okay, cool. So to get started with Modus, we install the Modus CLI from npm. I've already done this, so that shouldn't really do anything. And then we're going to say Modus new. This is going to create a new Modus project. Like I said, currently we support Go and AssemblyScript. AssemblyScript is very similar to TypeScript. So we will choose that. And this is going to skeleton out a new Modus project for us. And pull down the AssemblyScript SDK. And just starting off with like a very basic Hello World project. So there are a couple of interesting, well, first we're going to see what files we have. So a couple of interesting things to look at is modus.json. So this is our app manifest. This is where we configure the endpoints we want to generate, and then we would also add connections to any data APIs or databases here, or models that we would want to invoke in our app. And we can use local models with hosted by Hypermode in this development environment. So Hypermode can host models off of Hugging Face. We also host models like DeepSeek and Llama, or we can connect to a third-party model provider like Anthropic, OpenAI. We just declare that in this modus.json. And then the other interesting file is our index.ts, which just has a very basic function, hello world, takes an optional string, and returns a string. So let's say modus dev. And this is going to compile our project, generate a GraphQL schema, and run that locally. So we'll switch back to, this is the Modus API Explorer. You can think of this as kind of like graphical if you've used GraphQL before. And we can see here we have one query field, say hello, that maps to that function that we defined. If we run it, we get hello world. We can pass in our optional argument, hello FOSDEM. Cool. So that's like a very basic hello world example. That's not super interesting, though. Let's see what are some more interesting things we can do. Well, going back to this concept of the model native app, I think there are like some building blocks here that we really want to expose in Modus for building these model native apps. And this is where models are a first-class citizen in the application that we're building. We're not just building a chatbot. Like, we actually want to leverage our LLM to make decisions about control flow in our application. And so there's kind of three like building blocks or three steps here. The first is chaining data and LLMs together. So this is where like our internal enterprise data is fetched and passed in the prompt in the context to our LLM to make that output more relevant. This idea of function calling or tool use, which we talked about at the beginning, where we're defining functions for the LLM to sort of choose the control flow, where to fetch data from, what APIs to call to resolve our prompt. And then this idea of knowledge graph RAG. RAG is retrieval augmented generation, where we're fetching some data and passing that in the context to our LLM. That's very similar to that first chaining data and LLMs together. That's like basically what they call naive RAG. But with knowledge graph RAG, we can leverage the power of the knowledge graph, so the context of relationships in our data, to again provide more relevant context for our LLM. So let's look at this first example, chaining data and LLMs together. So we'll take a look at a basic demo app that I built. Let's assume that we're running like an online blogging website where you type in, like the text of your blog, and then you hit a button and publish it on the internet. And something that might be useful, some like AI-backed feature that would be really nice to add to that would be, one, could we generate the SEO meta tags automatically based on the content? Like, this is non-trivial because there's like a certain way you want to construct the meta description tag to optimize for SEO and these sorts of things. And then also, could we generate suggested titles based not only on the content of the blog, but also like in the style of the blog author? So that's going to be based on data that we have in the database that backs this online blog application. And so this is an approach called naive RAG, or retrieval augmented generation, where we're fetching some data from our internal database that's relevant for this specific query, the specific prompt that we're going to send to the LLM, and passing that along to improve the results. So let's stop this guy. I think this is the right one. So this is the code. We call this Modus press, and there's a couple of functions here. One is generate SEO. So you can see the prompt we're passing to the LLM. You're an SEO expert, create an HTML meta tag for this content. Here's an example of how we want to return it. And then we paste in here the post content. And this content comes from a Postgres database. Somewhere down here we have a query just to fetch author from a Postgres database that we have running locally that has a very small table here that just has one author and one bio. So let's run this. Modus dev is going to compile that. And we can also take a look at the Modus JSON for this project. And we can see here that the model that we're using is Meta's Llama model, hosted on Hypermode. So it's an open source model provided by Hugging Face. And then we're also connecting to just a local Postgres instance. Okay, so back to our API Explorer. So now we have a couple of new endpoints. We have generate SEO and post content. So let's start with SEO. So I wrote a blog post earlier. Actually, Claude wrote a blog post for me about eating chocolate in Belgium. So we'll copy that. And so again, imagine, this is the back end piece, the API piece, but imagine the front end of our app is some UI for writing a blog post. So we're writing this blog post about eating chocolate in Belgium, and we want to automatically generate these HTML meta tags that are optimized for SEO. And again, there's like a certain way that you write these where it's like verb first or something. I don't know how SEO works, but here's an example. Discover the art of Belgian chocolate making, blah, blah, blah. And what's interesting is like these LLMs are non-deterministic, so every time we run this, we get a slightly different response, which is kind of fun. Okay, so we're not like, that's not a RAG example. We're not like passing any relevant information there. So let's look at the example for generating a title. And remember, this one we want to be in the style of the author. So that's me. Travel category, let's say travel, and then here's the blog post again. And so what this is doing now is it's going to that Postgres database, looking up the author, reading their bio, and the prompt says, in the style of the author, based on this bio, if we had, my full post history, we'd pass those along as well. And here we're getting selected, suggested titles based on our blog content. And again, non-deterministic, so each time we get a slightly different response, which is kind of fun. Cool. So that's sort of the basic naive RAG approach. The next one here is function calling or tool use. And so this is how we want to implement this basic agentic workflow where the LLM is making some decision about the control flow of our app. And so we define some functions. You can look at the code for this. Let's stop this one. And here we go. Zoom in a bit. So in this example, we have a very basic warehouse that has some products. So we have things like shirts, shoes, trousers, hats, and we have two functions. We have get product info, so you can pass a specific product that will say, here's how many shirts I have, here much they cost. And then we have get product types that will say we have shirts, trousers, shoes, hats. And we basically define these as tools that are available to the LLM. And in our LLM call, based on the query that we have, and maybe just in the interest of time, I think I have this one in the slides. Yeah, so so we can pass a natural language query. This one says what's available to buy. And you can see here the response is the available products to buy are shoe, hat, trouser, and shirt. And we're also logging the functions that the LLM chose to invoke. And in this case, it just invoked get product list to return what are the products that you have. But if we ask something more complicated, this kind of runs off, but it says, how many complete outfits can I buy for $1,600, but I don't like hats? And so now you can see the different calls the LLM makes. Well, first it does get product info, shoe, hat, trouser, shirt, and then now it's getting the price for each one of those. And it knows enough not to include a hat in my complete outfit, because I said I didn't like hats. So it knows a complete outfit is shoe, trouser, shirt. And I can buy two of those because they cost $800 altogether. Very, very fancy clothing shop, I guess. Not somewhere I would be shopping. Okay, cool. So that's the basic idea of function calling and tool use. This next piece, knowledge graph RAG. So this is where we want to leverage a knowledge graph to improve the retriever piece, to improve the data that we're fetching to pass to the context of the LLM. So in the first example, chaining data and LLM together, the naive RAG approach, we're just doing a select star from author table where the name is my name. But we can do much more complicated, much more sophisticated retrievers to find relevant information. So for example, we could use embeddings if we're dealing with lots of unstructured data. We can chunk up a bunch of text, calculate embeddings, do vector search. We can also traverse the knowledge graph to find more relevant pieces of data. And this is going to depend on what the domain is. But typically, if we're dealing with unstructured data and constructing a knowledge graph from that, we'll have our domain graph, which in this case, we're going to build a movie recommendation app. So our domain graph, in this case, we have movies. We have users that have rated a movie. So this is like a mashup of the Movie Lens data set and IMDb. Movie Lens was used for, I think, the Netflix prize for finding movie recommendations. But anyway, we have a domain graph, but then sometimes we also build a lexical graph where we've chunked up unstructured data and then we're calculating embeddings based on that, and we can traverse from our lexical into our domain graph and sort of through there. There's this graphrag.com site has a lot of information on the different patterns, the different retrievers that are used for graphrag. But we have a couple minutes left, so let's take a look at this example. So we're going to use embeddings. Embeddings is basically just taking text and converting that to a vector of numbers. And then we can do what's called vector search or vector similarity search to find embedding values that are close together in vector space. So most databases support vector search now. Let's see if we have this one running, maybe. Neo4j. We want the back end. So we take a look at the code for this one. So we're connecting to a Neo4j instance. We've already calculated these embeddings using the mini LLM model, which is, again, hosted by Hypermode, provided by Hugging Face. And then at query time, we're basically just doing vector search to find similar movies. So let's take a look at the app here. Is this running? So we search for a movie by title. So I search for Cosmos. And we're looking that up in the database and then doing vector search to find similar movies based on the embedding of in this case, the plot. So that's the thing that we embedded in the database. So the code for this, if you're interested, is available in this Modus recipes GitHub repo. This one is specific for the movies kit. All the examples I showed today are in this Modus recipes repo. This just shows different ways to use Modus for building cool apps like that. And that is all I have. Again, you can grab the slides here, and I think we are out of time as well. So thanks, everyone, and we'll see you around.